AI systems are becoming infrastructure, and these papers show the hidden cost. They can appear accurate while quietly changing the rules across languages, inventing tools that do not exist, and inserting security debt into production code. A high pairwise score, a confident recommendation, or a passing pull request may be a dangerously incomplete signal. From GPT-4.1-mini and Claude Code to Codex and GitHub Copilot, the pattern is unreliable interfaces between models and real-world systems. We'll trace where those failures occur and which defenses actually hold up. Let's explore the first paper. LLM evaluators are biased across languages. Researchers at the University of Cambridge show that multilingual LLM evaluators do not use a language-neutral scoring scale, testing semantically identical instruction response pairs in 23 languages on RewardBench and its professionally translated extension mRewardBench. They evaluated 8 systems, 4 LLM as a judge models, including Aya Expanse 32B, Quinn 2.572B, Llama 3.170B Instruct, and Prometheus 14B, plus 4 reward models. Scores shifted by about 0.5 points on the 1-5 Likert scale, with lower resource languages generally scored more generously. For reward models, this pattern correlated with Common Crawl resource level at Spearman -0.81. The bias remained statistically significant across architectures and persisted in frontier judges, including OpenAI's GPT-4.1-mini and Qwen 3.32B thinking. Crucially, pairwise accuracy stayed above 90%, yet a single global threshold produced acceptance rate differences of up to 43 percentage points, potentially allowing harmful content in lower resource languages to evade safety filters and enabling cross-lingual reward hacking in RLHF. The authors link inflated scores to model uncertainty using summed negative log likelihood, alternative uncertainty measures, and semantic entropy, but regression tests show that language identity remains predictive after uncertainty is controlled. Per language offset correction reduced acceptance rate disparities by 60.9% on average, although code-switched prompts can defeat language identification and misapply thresholds. The paper therefore recommends multilingual calibration, language balance preference data, and reporting cross-language score consistency alongside pairwise accuracy. Let's explore the second paper, Skills That Don't Exist, a large-scale study of hallucinated skill recommendation in LLM agents. The paper presents the first large-scale study of skill name hallucination in LLM agents. Systems recommend downloadable skills whose names do not exist in any verified registry or GitHub repository. Evaluating 15,000 prompts across 12 configurations, including standalone models such as Claude Sonnet 4.6, Claude Opus 4.7, GPT-5.4-mini, and GLM 4.5 Air, plus agents such as Claude Code, Codex, OpenClaw, and OpenCode. The authors find that every configuration hallucinates. On real developer questions, the rate reaches 43.1%, and the study identifies 5,669 distinct fabricated names. These are exploitable supply chain targets. Claude Sonnet 4.6 repeated its dominant hallucinated name 7.8 times out of 10, while 410 names were shared across configurations, and 15% of hallucinated names exactly matched PyPI or NPM packages. Self-auditing achieved only 51% balanced accuracy, and hallucinated names were typically a median of 6 edits from real skills, defeating typo squatting filters. 4 defenses expose a security usability trade-off. Retrieval augmented generation, using a real skill index and 10 retrieved candidates, reduced average hallucination from 40.8% to 3.2%, but mainly by suppressing outputs. Even the strongest defended system recommended the correct skill no more than 1 time in 6. Self-refinement was substantially weaker, while cross-model voting removed many hallucinations at the cost of rejecting valid skills. The authors conclude that prompt engineering and model scaling are insufficient, recommending registry-level name reservations and authenticated exact lookup recommendation pipelines for ecosystems developed by Anthropic, OpenAI, and related agent platforms. Let's explore the third paper, Trust But Verify: Uncovering the Security Debt of Autonomous Coding Agents. The paper, Trust But Verify: Uncovering the Security Debt of Autonomous Coding Agents, by researchers at the University of Texas at San Antonio and De Novo Energy Solutions examines security smells introduced by autonomous coding systems including GitHub Copilot, OpenAI Codex, Claude Code, Cursor, and Devin. Using the AI Dev dataset, the authors analyzed 16,112 added file changes across 4,022 pull requests. Applying a 6-category taxonomy grounded in OWASP guidance, Center for Internet Security benchmarks, and GitHub hardening practices, an LLM as a judge pipeline based on quantized Qwen 3, 6, 3, 5, B, A, 3, B, F, P, 8, and Google DeepMind's Gemma 4, 2, 6, B, A, 4, B, I, T, F, P, 8 was validated against manual annotations. The central finding is that 38.9% of agent-generated pull requests contained at least one security smell. Supply chain integrity problems, such as mutable action or container image tags and unpinned installations, represented 82.3% of all detected smells, while hard-coded credentials accounted for 99.6% of critical severity findings. Manual investigation confirmed 74 genuine credentials. Human collaborators introduced 67.6% of them, compared with agents introducing the remainder, and reviewers or security bots failed to comment on 81.1% before integration. The judge achieved 0.836 F1 on the validation sample, but its 0.775 recall indicates that reported prevalence is likely an underestimate. The authors conclude that agent-generated code requires context-aware, point-of-collaboration guardrails rather than reliance on conventional review pipelines alone. That's a wrap on today's AI paper highlights. Thanks for watching.